Welcome back, biochemistry students. In this video, what we're going to take a look at is the hydrolysis of a phospholipid under acidic conditions. Now, it seems like a lot of gobbledygook, but we'll work our way through this. Now, to get us started, this right here is a phospholipid. Now, this looks very similar to a triglyceride, which we saw in a previous video. A triglyceride is where we have this glycerol structure here, the 3 carbons, and then attached to the 3 carbons, or the glycerol, would be these fatty acids attached through ester linkages. Okay? Now the only difference is this time we have a phosphate group attached. That's just what makes it different. Now the ester linkages, if we remember what an ester is where we have the carbonyl group, and then the carbonyl group has a carbon chain coming off of it, and then here we have an oxygen, and then another carbon. So this right here would be a carbon ester group, and then a phosphoester group would be, instead of a carbonyl, we have a phosphorus double bonded to an oxygen, and then over here we have an oxygen attached and then a carbon. Okay, so this here would be a phosphate ester, and then on this side as well, we would also have a phosphate ester. So there's 2 of them here because we have the carbon chain coming off of this oxygen and a carbon coming off of that oxygen. Okay, so just kind of getting the lay of the land here, what's going on. Now this reaction, what we're going to do is we're going to react this here with some water. So plus H2O, and in fact, I'm going to rewrite this. I'm going to write this as HOH, so that way we can see that it breaks apart. So HOH, and then we're also going to be reacting this under acidic conditions. So we might say HCl might be an acid, or we could also write it as H+, okay, just acidic conditions. And what we're going to do is we're going to break apart these water molecules like this, and we're going to break these ester linkages and just break this whole thing apart. Okay, so now I'm going to rewrite this as we're breaking this apart. Now the last video that we had, we saw that we could break these apart and form fatty acids. Okay, so we're going to break this apart and form fatty acids. We're just going to break it right here, and then we're going to end up with a fatty acid up on top. Okay, so that is going to give us here, let's see, a oxygen, and then double bond O, carbon, let me rewrite that there. Okay, that's going to give us a carbon, double bond oxygen, and OH like this, and then our carbon chain coming off like that. We're going to have another one here, and so that's going to be OH. Let's see here, carbon, double bond O, and then okay, all right, so those are our 2 fatty acid groups there. So I'm just going to label these 2 fatty acids. Okay, that's 2 of our products. And then we're also going to end up here breaking this apart. Now when we break apart our phosphate diester, there's 2 ester linkages here. We're going to end up here with our phosphate group forming OH bonds, just like we did here. Okay, so that's going to give us our phosphate here, phosphate double bond oxygen, okay, just like that. So that's this right here. And then we're adding water to it, so we're going to break apart this bond here, and we'll end up with OH and OH like this. What we'll end up doing is breaking these bonds here, and then we end up with this molecule here. Now, I think I'm missing an OH up here, an OH here. Okay, and so this right here becomes phosphoric acid. Phosphoric acid. And phosphoric acid has a formula that's H3PO4. Not that you need to memorize that, but you might see that in your textbook. Okay, so here's phosphoric acid, and then what happens to this linkage right here? Well, this ends up becoming an alcohol. Okay, so we ended up with an OH coming off of this right here, and then so this gets broken apart and we end up with an alcohol. So I'm going to go like this and go OH like this, and some carbons like that, and that's going to be some alcohol. An alcohol there. And then the one thing that we're missing is our backbone here. This right here is our glycerol backbone, and so we're going to end up with 3 carbons with 3 hydroxyl groups coming off of that. And so if I were to draw that, we'll do it here. I'm going to go carbon to OH like this, H, and then carbon H2, OH, and then OH like that. Okay, and this is our glycerol group, group. So G, glycerol. Now, if I were to count up all of the waters that are involved in this reaction, I'm breaking bonds here, 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 and here. So this, if I were to balance this, I should put a 4 here. There should be 4 waters. There should be 4 waters there to balance this out. Okay, hope that helps.